Hello, today we are going to be talking about factoring perfect square trinomials. So we're actually going to be using the same exact method of factoring that we have used in the past. I have a video on that. I will place a link in the iCard above. And so when we are factoring, the only thing that's going to change in this example is we're going to wind up with two identical factors, which means I can rewrite it using an exponent. So we're going to see what that looks like after we go through the same exact process. So to factor each expression, we're going to start with the sum and product. So the sum, in this case, is positive 6, and the product is positive 9. We need to identify the factors of 9, which are 1 and 9, 3 and 3. If you need to use the graphing calculator for this to identify all of the factors, by all means, I actually have a video on how to do that as well. I'll place that in the iCard now. So we have to identify two factors that multiply to 9 but also add to 6. The answer is 3 and 3. They are both positive. So I set up my two sets of parentheses, and I have x, and now my two factors are plus 3 and plus 3. You'll notice that I have two identical factors. So this is a factor, x plus 3, and the other factor is also x plus 3. That means that this is a perfect square trinomial. Okay, because when I factored it, I wound up with two identical factors. So think of the number 9, right? This is a perfect square because two factors that are the same are 3 times 3. So since I have two identical factors, I can rewrite this as x plus 3 squared, just like I can rewrite 3 times 3 as 3 squared. Okay, so this is really the only difference, is being able to rewrite your two identical factors as a factor squared. All right, so let's take a look at example number 2. Once again, I have a sum of 10 and a product of positive 25. I identify all of the factors of 25. The two that will work are 5 and 5, both positive. So I rewrite as x plus 5 times x plus 5. And once again, since I have two identical factors, I can rewrite this as x plus 5 squared, and we are factored completely here. So let's take a look at 3 and 4. You'll notice that these two examples have negative sums, okay? So we have a sum that's negative 14 and a product that's positive 49. I list the factors of 49, 1 and 49, and 7 and 7. You'll notice that 7 plus 7 makes a positive 14. So when I have a positive product, I actually have two versions of this table. The positive version and then the negative version. So when the positive version doesn't work, switch everybody to negatives and then see if that works. So negative 7 and negative 7 make a negative 14. So those are what goes into the parentheses. I have x minus 7 times x minus 7. And you'll notice that this becomes x minus 7 squared. Okay, if you'd like to try the last one on your own, by all means. So once again, I have a sum that is negative 16 and a product that is positive 64. Okay, so we can identify all of the factors. I'm not going to do that right now. I'm going to skip ahead since we can follow the same pattern, that the last number is a perfect square. And if I use that perfect square set of factors, they will also sum to the middle term. So this is actually going to be 8 and 8. Once again, positive 8s are not going to work, but negative 8s will. So this is x minus 8 times x minus 8, which is x minus 8 squared. Now, if you had to list all of the factors in order to figure out what makes negative 16, that is perfectly fine. I just took a shortcut here. So thank you so much for watching. I hope you enjoyed a Heisig creation. Bye-bye.